How's it going, everybody? In this video, we're going to take a look at a different variation of the cryptography than we've taken a look at so far, where we've been using a lot of the defaults. The default transform set and the default crypto IP2 proposal and the policy. And all that's well is great if you want to go with the default operations. I won't necessarily call it easy, but that's pretty much what it is. You're just relying on what's already been deployed. But sometimes you might have a situation where you have to meet certain criteria and the defaults just don't meet that criteria. So assuming that you know the defaults are there and all that type of stuff, you have to go in and play around with it and get stuff to work. So in that particular case, what we want to do is we're going to actually turn off all of the defaults. And then we're going to go and configure CSR6. And we're going to do a peering with CSR6 to CSR3. And the idea is to use eBGP and then do redistribution. So this would be a case where you don't want to use EIGRP and you want to use BGP for the peering. There's nothing wrong with that. You could totally get away with it. So that's what we're going to go do. We're going to do a GRE over IPsec with the, just like we did with CSR3 to CSR4, except for this time we're going to be doing it where we turn all the defaults off. So I'm expecting things to break on CSR3 and CSR4. Or I'm sorry, between CSR3 and CSR4. And you might wonder why. Well, the moment you turn the defaults off is a major turning point, because now you've turned them off. That doesn't necessarily get rid of the defaults, because they're still technically there. You just disabled them. What ends up happening is anything that's currently working will continue to work, right? But the moment you turn off a bunch of stuff and you switch over to manually defined variables is when things are bound to break. So unless you've tested out everything, it's likely that your IKEv2 configurations are not going to match, or there won't be a variable that'll be out of place. And especially with the phase 2 with the IPsec capabilities, you turn off the default transform set and default profile, and then you run into a situation where unless you've created a profile, or created a transform set, then you're going to run into problems. So what we'll have to do is on CSR3 is I'll go ahead and get CSR6 up and running. I will flap the tunnel on CSR3, and I will have to get that working again. So we'll make sure that it's operational. The key thing here is to know what the configuration you're doing and what it's going to affect. If you're turning off the smart defaults and you've got smart defaults in use in order to deploy things, it's actually funny, you won't actually be able to turn anything off. And you're like, wait a minute, you just said we are. Well, you can't turn something off if it's in use. So we're actually going to have to shut down the tunnel, configure, turn off the smart defaults, configure specific things for it, so the transform set, and then call that. Then we're going to have to create all of the IKEv2 variables, get them all up and running, and stuff like that. So it adds more complexity to the design and to the implementation when you turn off the defaults and start using the defaults you need, or the variables you need, versus the defaults the variables that are attached to the defaults that you've been using. So let's go ahead and go and do all of that stuff. So I'm going to come over here and I'm going to interface tunnel 34, and I'm just going to shut the tunnel down, because at this point in time we don't have since we're going to be turning off stuff, we need to turn this stuff off, and we don't want to have anything in use at the time. So I can do it on CSR3 side. So if I was to do the no crypto IPsec transform set and then default, that'll turn that out. So no crypto IPsec profile default, and then no crypto IKEv2, and it's going to be the proposal default. Cannot remove remove as proposal is in use. So that's just an example of what I mean by that. So the proposal is in use. So what I'll have to do is create a new proposal and create a new policy. So I was to try to say no policy default. That will be that should disable it because the policy isn't in. So if we were to, there we go. So I kind of figured that would be the case because you have to call the proposal from the policy. If you turn the policy off, the proposal gets deactivated, and that's pretty much everything. If I look at the show crypto IKEv2 proposal, that's been disabled. If I look at the policy, it's been disabled. If I look at the profile, we have one enabled at the moment, but there is no default policy, or I'm sorry, profile. So if we show crypto IPsec transform set, it's been disabled, and the profile has been disabled. So we've disabled all the smart defaults. The next one to do is go to global config, and we're going to start getting all this stuff up and running. So what we're going to have to do is we're going to do a crypto IKEv2, and we're going to say proposal, and I'm going to type an IKEv2 underscore proposal. And underneath here, it says that IKEv2 proposal must either have a set of encryption algorithm other than AES GCM, an integrity algorithm and Diffie-Hellman group configured, or an encryption algorithm AES GCM, a PRF or pseudo-random function algorithm, and a DH group configured. So thanks, Cisco. We're going to type in the encryption. In this case here we'll say the simple AES CBC 128. That's a pretty standard setup. We're going to do the group that we're going to set up is going to be group 2. Well, we'll do 5 and 2. And we will type in the integrity. We'll specify is going to be SHA and SHA-256 and SHA-1. And that's pretty much it. That's all we need to worry about. Because most of the platforms we're dealing with are dealing with AES 128. So 128 bits of encryption. So it's going to type in the crypto IKEv2 policy, and we're going to create one, IKEv2 policy. And underneath here it says a proposal will be the IKEv2 proposal. Just like that. Now there's a variety of things. We have address and stuff like that, local. And we can specify values, but we don't have to do anything there. And we can do front door VRF or match FVRF, and then we can specify any. So we'll just do that. And if we don't specify anything, it's going to go ahead and use the global. So what we're going to go do now, if we do show run section IKEv2, we can see in the policy we've specified just any. So the configuration we've typed in has taken, which is great, which means that we're doing everything that we've done so far is working the way that we need it to. Now the next thing that we need to do is we need to go and create a IPsec transform set. So the crypto IPsec transform set that we need to specify, we're going to type in IKEv2 tset, and I'm going to specify ESP AES, which is 128 bits of encryption, and then ESP SHA HMAC. So is this going to be the next generation encryption? It's not, but we don't need to really worry about that right now. I'm going to then go do show run section crypto, which the only thing we have, and the one I'm looking for is the crypto map. So I'm going to come in here to the crypto map, and I'm going to type in set the transform set to be, and the transform set that I just gave this guy is IKEv2 tset. And that's pretty much all we have to do. That should fix our configuration to CSR4. So if I type in interface tunnel 34 and I know shut it, and there we go. So that is just our way of going through and whatever changes you're going to make those changes, get things that were already operational up and running, and make sure that you don't deviate. So as long as your attributes on both sides match, you get results like this. You know, it worked right away. It did what we needed to do. We tied what we needed to tie where it needed to be tied. So let's get rid of the philosophical aspect of it. We disabled the smart defaults. We created the smart default. We created the proposal and the policy, and then we went underneath the crypto, or we created a transform set that would match what we knew CSR4 was configured with. We created that, and then we went underneath the crypto map and applied the updated configuration to it, and voila, we have the adjacency back up and running. So now what I'm going to go do is do a very similar situation. I'm going to be reusing the proposal and the policy. I'm not going to mess around with those because they're already in play. I will be creating a new keyring and a new profile to go point over towards CSR6 to get the EBGP peering up and running. So I'm going to go in here, type in crypto IKev2 keyring, and I'm going to say the keyring is going to be IKev2 CSR3 CSR6 keyring, and I'll type in peer is going to be CSR6. The address is going to be 61.0.0.6. The pre-shared key local will be CSR3. The pre-shared key remote will be CSR6. And then we will go to the crypto IKev2 profile. IKev2 profile, and this one's going to be CSR3 to CSR6 profile. I don't need to get into the GRE over IPsec because that's going to be the same thing that it's been. I'll type in the local. The authentication is going to be pre-share key. Local will be pre-share key. Authentication remote will be pre-share key. The identity local will be address, and we'll specify 31.0.0.3. And then we'll type in match the address, or should say match identity remote, and we're going to say address of 61.0.0.6 with a /32 mask. And that's pretty much actually the keyring local, and the keyring, we'll scroll up here real quick and grab the keyring name like that. And there we have it. So now we've got that one squared away. The next thing I'm going to do is crypto do show run section crypto map. So we're going to type in crypto map cmap. We're going to give it 20 and then IPsec isocamp. I'm going to set the peer to be 61.0.0.6. Let's set the transform set to be IKev2 tset. Set the IKev2 profile to be this name right here. We're going to match the address IKev2 GRE over IPsec, because remember we created one that's GRE to GRE, so we can reuse that. And then that is pretty much all we have to do. Do show run section crypto map, and there we have it. So everything's been squared away and applied the way that it needs to be. Now I get to go over to CSR6 and repeat the process. So I'm going to go over to interface tunnel 36. The tunnel source is going to be gig 1, the tunnel destination 61.0.0.6, IP address of 10.3.6.3/24, and then route, I was about to jump this into EIGRP, but I had to stop myself. So on CSR6 we're going to do a very similar situation. We're going to go to we're going to roll with the configuration. Right now there's nothing going on. Do show run section IKev2. There is no configuration in place, so we're going to say no crypto IKEv2 policy default, and proposal default, no crypto IPsec transform default, no crypto IPsec profile default. So now we've disabled those. No crypto IKEv2 profile default. Okay, that's what I thought. So that means we have to create the crypto profile and the proposal and the policy. So do show run section IKEv2, and I'm gonna go grab these couple lines of config right here. And the reason why I'm doing this is because I want these to match explicitly. And why worry about matching on it when you can just copy and paste? So like that. There we go. So we have that guy squared away. So we have the proposal and the policy out of the gate day one. The next thing I want to do is the IP access list extended is going to be the IKEv2 underscore GRE over IPsec ACL and permit GRE any exit out, and then we're going to go to the crypto IKEv2 profile. The profile name is IKEv2 CSR3 CSR6 profile. We're going to actually, I need to do one thing. Crypto IKEv2 keyring is going to be IKEv2 CSR3 to CSR6 keyring. The peer will be CSR3. The address we're going to match on is going to be 31.0.0.3. The pre-shared key local will be CSR6. The pre-shared key remote will be CSR3. Get out of that. Hit the up arrow half a dozen times until I get to there, and then we're going to type in keyring local, and we're just going to grab this guy right there. The authentication pre-share or local will be pre-share. Authentication remote will be pre-share. The identity local will be address 61.0.0.6. The match address or match identity remote will be address of 31.0.0.3/32. And then now that I have that squared away, I can go to the crypto IPsec transform set. It's going to be IKEv2 tset. And we're going to do ESP AES and ESP-SHA HMAC. Exit out of that. Crypto map CMAP 10 IPsec ISACamp. Set the peer to be 31.0.0.3. Set the transform set to be, oh, it's right here in front of me. Where'd it go? Right there. Set the IKEv2 profile to be that guy. Match the address of IKEv2 GRE over IPsec ACL. I believe that's what I called it. Do show IP access list. Yes. Right? IKEv2. Yeah, I'm just wondering. Oh, wait, why does that look weird? Why do I have two of them showing up? Do show run section access list. When in doubt, check it out. Like, oh, one's a little v, one's a big V. You see that? One's a little v, one's a big V. Right there, little v, big V. So what I'll do is I'll come in here and I will say no to this. match address, and I'll just match on the one that I know is legit. And then I will exit out of here and type in no and pull this guy out. So there we go. So now I will have to go to do show IP route. Cool. Do ping 31.0.0.3. Perfect. I will go to router EIGRP do show run pipe include router EIGRP1 redistribute static, and then metric. There we go. Next thing I need to go do is do show run section crypto map. Make sure I'm not missing anything in the crypto map, which I am not. I'm going to go ahead and type in the interface tunnel 36. The tunnel source is going to be gig1. Tunnel destination will be 31.0.0.3. IP address will be 10.3.6.6/24. And what I'm going to go do now is do ping 10.3.6.3. And oh, you know what? Let's see. Let's see here. I can ping the remote side. Oh, see, okay, that's actually a good sign for me, because then I know it's receiving the traffic, but it received it as it received it as GRE, and that is an IPsec packet. It says received an IP packet. Does it specifically state it? I'm not seeing the input. Received not an IPsec packet. So it's already expecting the packet over on this side, because if we do show run section crypto map has already been configured and applied. So on CSR6's side, I have to go to do show run interface gig1, interface gig1, and type in crypto map cmap. So that'll turn crypto on. And now if I go to ping, let's do ping again. There we go. So now it's being encrypted, which is what I want to see. So now if I do show crypto IKEv2 SA, I have an active SA over to CSR3. Now, question is, will I be able to form a BGP peering over the peering? Let's go try. So I'm going to type in router BGP6, no BGP default IPv4, neighbor of 10.3.6.3, remote AS of 3, address family IPv4. I'm going to go ahead and I'm going to activate the peering, go over to CSR3 and do the same thing. I'm going to go to router BGP3, no BGP default IPv4, neighbor of 10.3.6.6, remote AS of 6, address family IPv4. Go ahead and activate the adjacency. I want to see if I can get the peering up first. So that should come up momentarily. There it goes. So the BGP peering is up. And now what I'm going to do underneath this, guys, I'm going to type in redistribute EIGRP. In this case here, I'm going to do 1 and then do that. And I'm going to type in do show run section or pipe include router EIGRP VPN, address family IPv4 autonomous system 1. I'm going to type in topology base redistribute BGP 3, and then the metric of, let's see, 155, 1500. So I should be able to, that'll redistribute those routes. So do show Let me go over to CSR6 now, and I will go to redistribute EIGRP 1, and then router EIGRP 1, redistribute BGP 6, metric value of, and there we go. So now if I go to CSR8 and I do a show IP route VRF S6, so on this guy here, I think I know what the problem is. So I was doing some testing with the IPsec VPNs. So on switch 10, we do a show VLAN brief. I have placed gig 0/2 into VLAN 11. So let's go to interface gig 0/2 switch port access VLAN 6. And that should fix that. So show VLAN brief, that's been placed where it needs to go. CSR8, show run pipe include router. There's my 6 has gone down, so if I go to do show run EIGRP, router EIGRP VPN, address family IPv4, VRF S6, autonomous system 1, network of 10.8.6.0/24. Or I'm sorry, not 8.6, 6.8. There it goes. Not uncommon subnet. Let me go just adjust that real quick. CSR6 has got a problem. Do show IP interface brief. Interface gig 2. IP address of 10.6.8.6/24. That's an easy solution to, easy problem to resolve. Do show run section EIGRP, unless I go underneath here and I have the wrong IP address. So we'll go ahead and we'll pull that guy out. Network of 10.6.8.0. There we go. So that should resolve that problem. So we have an adjacency up now. CSR8 should learn those routes. Show IP route VRF S6. And there we are. So we're learning a bunch of routes through EIG or via BGP. So we can tell that because they're external routes. CSR7, same thing. Show IP route. We're learning some external routes. 10.6.8. So if I was to do a trace route to, for example, 10.6.8.8, sourcing from, let's say, what does CSR8 know about? 10.1.0, so we'll do loopback 0. So, loopback 0, source from loopback 0 numerically. We jump across. It's a little high, but that's okay. But we get there, and that's the point. So we jump across the wire. Actually, I need to go to 8. So we should jump across and then hit 8. There it goes. It's just a little high. That's okay though. As long as it gets there, that's all I really care about. So we have that going for us, and then that's basically how this comes into play. Now let's go back and check on CSR3. So I saw a flapping route. Let's see why EIGRP is flapping. So show IP EIGRP neighbors, and we have a queue count. So in this case here, sometimes this does happen. So show crypto IKEv2 SA, and I have appearing to 4. Let's check off 4. And show IP EIGRP neighbor. So this guy is not formed. So show crypto IKEv2 SA. There is an SA. So let me go up to interface tunnel 34. Let me shut the link down. Sometimes flapping it fixes it. So we'll flap it on this side, and then I'll flap it on CSR3 side. So interface tunnel 34. I'll shut it down. because we did make a change, and sometimes EIGRP can be a little wonky. I'll go ahead and no shut it. So that'll bring the protocol up, and then I'll come over here and no shut it over on this side. Okay, so 34 is up now. So if this doesn't work, I'm not terribly worried about it. So let's see what is going on here. So CSR4 is not seeing the connectivity come across. So this is one of those times where you would show crypto IKEv2 SA. You have a connection, show crypto IPsec SA, and you are sending. Okay, so right now we have unidirectional traffic. So pay attention to this right here. We have packets being encrypted but not decrypted. So let's go and take a look at pipe include PKTS, peer, and ident. We want to pay attention to this right here. So we've got traffic going out but not being decrypted. So we have to figure out why that's happening. So let's do a show crypto IPsec transform set, ESP AES, and we're doing show crypto IPsec transform set. Okay, so I don't think that one tunnel doing the other one doing transport is going to make much of a difference. So show crypto IKEv2 SA. I have an SA to them, so show crypto IPsec SA pipe include peer to 41.0.0.4 pipe include PKTS and ident. So we are sending and receiving traffic from him, but he is not sending and receiving traffic from us. So let's do a clear crypto IKEv2 SA. Let's just do a complete clear. Let's clear. Okay, that's an adjacency there. So show IP EIGRP neighbors. And it looks like we're good now, which is good. That's a good thing. We want to make sure that we're clear. So show IP EIGRP neighbors. Okay, it looks like we're clear. Let's look at that again. Yep, it looks like we're good to go now because we're seeing traffic coming in and out equally. 516, 398. Now we're at 602, 464. Good. So we're squared away there. Now I'm going to go to CSR7 and do a show IP route. We can see routes traffic coming across, which is what we want to see. And those routes are propagating. So some of this stuff is going to be crypto-based stuff. Some of this will be routing protocols being affected by crypto-based stuff. So I like to mess around with this stuff because you never know what you're really going to get tasked with or anything like that. I'm hoping that if I spend enough time playing around with this stuff, that anything that they throw at me, I'll be like, oh, got this. But then again, you can't think of every possible scenario. I mean, it's just logically impossible. I mean, you never have any time. And I happen to like life. So just wanted to troubleshoot that. So I like to have some live troubleshooting in here. That was unexpected, but then again, it's good to have. So with that being said, everybody, thanks so much for stopping by and hanging out with me in this video, and we'll catch you guys in the next one.